All right, so we're going to do a video on Chapter 6, Section 6, which is actually systems of linear inequalities, exactly how you did systems of equations in the sections, a couple sections back. You're doing of systems of inequalities. However, you don't have to choose, am I going to graph, am I going to substitute, am I going to eliminate? You're graphing, okay? And what that means is you're graphing two inequalities and finding what section overlaps in your shading. And that means that whatever points are in that little section, that's where your solution to both inequalities is going to be found. Okay? So let me clarify that a little bit by actually working a problem. Chapter 6, Section 6 is about systems of linear inequalities, like I just said. So what they're asking you to do is to graph two inequalities. Let's go to problem 1 on page 400. Okay? The first inequality is y is greater than 2x minus 3. The second inequality is 2x plus y is greater than 2. Okay? So what does that mean as of this point? What do you need to do? You're going to have to take the second inequality and you're going to have to put it into y equals mx plus b form, because right now you don't have that. You've got y on one side, 2x on the same side, and you can't have that. So the first thing you need to do is move that 2x over to this side. Okay? Now you've got y is greater than, and also remember the associative property of addition and subtraction means that you can flip 2 minus 2x and make it negative 2x plus 2, and you're going to get the same answer. So we want to do that so that we immediately get it in the proper format. Okay? Let me change that negative sign. All right, so now we have our two inequalities that we need to graph. We've got y is less than 2x minus 3, and we have y is greater than negative 2x plus 2. Now we need to graph these two lines. So let's draw us a graph. And you guys actually have graphs on your dry erase board, so just use those. Okay? The first the first inequality we're looking at right here, y is less than 2x minus 3. What is your y-intercept? 3, negative 3. Okay? So you're going to go down to negative 3, and that's the point where you're going to start. Okay? And now what is your slope? 2. So 2 over 1 would be your slope. So how do you now create your line? You go up 2 over 1, up 2 over 1, up 2 over 1. So on my board, on the board that you're looking at on the wall, this is a estimation, okay? But yours should be accurate. You should go up 2 lines over 1 line, up 2 lines over 1 line. And then before you draw your line, you have to think in your head, is this less than or greater than? Or is this less than or equal to or greater than or equal to? If it's less than or equal to or greater than or equal to, you're going to have a solid line. Okay? We just have less than. So our line's going to be dashed. Like so. Okay? Now you have to say, where am I supposed to shade? Well, you have a less than sign, so where are you supposed to shade? Below. So go ahead and shade below. And I'm going to use horizontal lines and vertical lines for both of my shading so that you'll be able to see where they overlap because it'll be crossed. Okay? So we're looking at our second equation, which is right here. And what is our y-intercept? Positive 2. So we go up to positive 2 on our y-intercept. And what is our slope? Negative 2. So that means our slope is negative 2 over 1. Okay? What does that mean for you? That means you're going to go down 2 and over 1. So we're going down 2 over 1. Down 2 over 1. Down 2 over 1. Okay? Once again, mine is just a slight estimation of exactly what you're supposed to do. Okay? So it's a greater than sign. What does that mean for the line itself? It means that it's dashed. So go ahead and dash the line. Okay? And then once you have a dashed line, now you need to figure out where you're going to shade. Okay? Because it's a greater than, you're going to shade above. So you're going to shade everything above your line. So I'm going to use vertical lines. Okay? So you can easily see which area overlaps. Okay? In this one, there's a huge area of overlap, which means any point inside of that should be a solution to the question. Okay? So how do we check that? We pick a random point in that overlapped area and see if it works for both inequalities. All right? And because they're inequalities, usually you will have a large area because like we pointed out in the other video, you don't just have one thing that will satisfy your answer. Okay? So you pick a random point over here in this area. I'm going to pick 10, positive 1, just so we're safe and make sure that my estimation is not wrong. So our ordered pair we're going to use is 10, 1. Okay? So let's see if it works in both of our equations. 10 is our x, so we're going to put in 10 and we're going to put in 1 for y on the first one. So 1 is less than 2 times 10 minus 3. Is 1 less than 17? Yes. So that means that that is a point that satisfies the first inequality. If we check the second inequality, we'll be good to go. Okay? The second inequality was 2x plus y is greater than 2. Okay? We substitute our numbers in. 2 times 10 is 20, plus y, which is 1, is 21. Is 21 greater than 2? Yeah. So our point that we chose way out here in this shaded area is a point that satisfies both inequalities. So did we graph it correctly? Yes, we did. Finally.